what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show increases the live audience, of course, but this in turn increases the chances of a more diverse panel. So please share the show as my kid knocks the mouse. Hopefully he hasn't knocked everything offline. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Mark Doxy, P Mars, Jimbo, Jose, Sleeping Warrior, and The Plain Truth. Good to have you all.
And PJ Aristarchus, don't forget that.
If you got something to say and you stay in the chat, either you are a keyboard warrior or you are a coward. Thank you.
I don't think
Can I ask
Mark's
a question? Serious answers are required. Is there any examples in real world, and I'm asking from a position of ignorance, I'm asking genuinely, is there any examples where a force can be exerted on an object and force a movement, but there's no object causing said force?
Hello, guys.
Hey, Arwen, good to have you.
Well, there's a little device you can buy for $5 on eBay, and it's some foils and a little glass bulb. And laser lights can spin the foils around like a cartwheel. So it's basically a light propulsion.
Light causing it, right?
Yeah, light is a force, as a
So we need
push.
something that's a force that doesn't have the laser creating it, causing an effect.
All I can see is potential levels, you know. If the ground, the earth, is the lowest place something can be, like a rock, and it's on a hill, it's elevated, well, however high it is potential energy. It can go down to whatever ground level is, roll down a hill and release that energy. You know, it's like, you know, energy often, like we measure it, we know some of the values. Car outputs, the torque is foot-pound seconds, right? Horsepower and output, it's the torque and foot-pounds. Well, vertically, if I lift a can, one pound can 1 foot off the ground, I'm holding back 1 foot-pound of potential.
So if you take a can and you move it 5 feet to the left of you, then why doesn't it jump back to its origin point?
Talking about gravitational potential energy.
Because I've applied a lateral force to it, moved 5 feet over, and that's now its potential energy, and ground rest is below it at that point, where it should be. Like an apple falling in a tree, falls straight down. It grows there, it falls there.
Okay,
right?
so potential energy only counts for things going down, because things don't, like,
no, they can go like a rock rolling down a hill. It might have a lot
they
of
don't
stored
fall
potential
sideways,
energy
so why
above
not?
a certain
Why
point vertically, but it might roll down 100 yards.
That's gravitational potential energy.
No, rock rolling down a hill.
No, it's gravitational potential energy.
It's stored energy till it's released.
No, it's not stored. You can't measure it. Doesn't leave any energy. Is measurable. It is expressed in energy, heat,
below it,
tension,
hold
all
on,
these
hold on,
things.
everybody, hold on. Nobody's addressed a word that P has just said. Clearly, you were paying attention during the break, P. No one's addressed what he's just said.
There's no gravitational pull, P.
No, he didn't say that. He said that's... Hold on, Arwen. His words exactly were, that's gravitational potential energy. Nobody's addressed him.
That's what I'm saying. Like you're saying potential energy, but it's gravitational potential energy to be specific.
This is
or
the whole
technical.
argument for me. And I was going to ask Rumpus if I got the chance, but I didn't get the chance. How has he decided that the gravitational force is a pulling force as opposed to a pushing force? How do you experimentally detail that is the case? I would ask you the same, P. Mars. I do agree myself that there is this. I agree with Arvin, as I say, we are living in an enclosed system. There is a barrier between us and the waters beyond, and we are underneath that reactionary force. We live in a broken system. This is about us piecing together the truth of our reality. We can forego a lot of the traditional science that's presented to us as truth, but we need to sort of venture into these new areas and start reconsidering systems as a whole, the system as a whole. So that would be my question to Pima.
Well, I saw an experiment a guy did with a balloon, and he used a car acceleration to simulate gravity, right? Because gravity is acceleration, an acceleration force. So he used the car's acceleration. So he had air in a balloon, right? And the it was tied to the ceiling on a string on a balloon. And when he accelerated, right, the balloon, what did it go? So when he accelerated, it went backward.
No, forward.
No, forward.
How does that work?
Because the air that it's displacing when he accelerates goes to the back of the car, forcing the helium balloon to go
that's when
forward.
he has a helium. He uses so he uses one balloon that has air and one balloon has helium. And when he has the air balloon, it goes to the back with the rest of the air. But the helium, it gets pushed forward when he accelerates.
Yeah, so that's called displacement.
Right, I think.
And the energy is coming from a gas pedal and an engine.
That shows
not
how
a natural phenomena. It's
right, but that it's an experiment. The gas is to simulate energy or gravity.
I'm sorry to do this to you, P. I
something
can't
he
not
thinks,
do this
but
to
it's not
you.
an experiment.
Hold on. It's not an experiment, right? An experiment is the expression of a hypothesis. It is your hypothesis test. That's what an experiment is. So in this instance, there is no hypothesis. It's not science. I'm not doing this to be mean. I jump on flat earthers for the same. I don't know what your position is and I don't care. But if you call it an experiment, you're going to get me saying, well, what's the independent variable? What's the dependent variable? What is your formulated scientific hypothesis? Show me the systematic experimentation. And you've got none of that. So if you want to call it...
yeah, you do.
Okay,
it has all those things. It's totally an experiment, Nathan.
Okay, I'm going to leave it here, P. And just say to the audience, P is wrong. It is absolutely not an experiment. I won't have the argument with you, P. If you want to now assert that it is, feel free.
And it was mostly about falling objects and not necessarily tethered balloons. It was the menu.
Pete's asking, how do we know it's a force that pulls down and not up or whatever, right?
Let me give
I'm just saying that experiment proves it.
Let me give a brief scenario. You don't have to answer immediately. Just a brief scenario. We've all heard of Auguste Piccard, right? So Auguste Piccard is placed on a scale, weighing scales on the ground, or a spring tension or something, and the result of the reading is noted. Now, as he is making his way up through the atmospheric layers, what should we expect to record in terms of the measurement on the scales? I think it might take a bit of thinking about, but I think
I can answer that.
Telling itself.
Without experiencing
if he is
it
high up
firsthand,
and he's in a stationary
Hold on,
position,
Travis.
then
Arwin
the
was
scale will
first.
give the exact same result. But as long as he is motioning upward, the scale will give a higher weight result.
Right. Isn't the thing, though, and we can imagine that, I think he was said to, I don't believe that story in the first place, but I think he was said to reach a height of maybe 60,000 feet. We know modern technology can take high-altitude balloons up much higher than that.
I think 10 miles.
Right, doesn't it appear that he's continually gaining speed, right, as he goes up until eventually you have a decomposition of the balloon itself or a bursting of the balloon? But yeah, it's interesting. What would the scale itself measure? My own thoughts on it that it would his weight would ever increase until you get to a certain point at the top. And for me, thinking it through, it does prove a gravitational force, a downward pushing force. But once again, we have to.
It doesn't prove it, but you're also wrong, because buoyancy, like air bubbles in the water rising and balloons with helium in them rising, do not accelerate. They move at a constant speed upwards. They don't accelerate. It's only when you introduce mechanical or chemical forces, like a rocket propulsion, that you actually accelerate upwards. But yeah, natural buoyancy effects, they're not force, they're effects.
Yes, but Arwen, this is why the helium balloon bursts, right? Because it's ever expanding. It's expanding
upward at a
When you
constant
release
rate.
air deep underwater, air bubbles, they expand as they rise. So
Yeah,
I don't
but
know
they
if
move up in a
acceleration
constant
changes.
rate. They don't accelerate upwards.
And
they don't
okay, Arwen, we've heard you
slow
say it
down.
3 times. Thank you.
Yeah. This is why the balloon bursts. This is why it comes to an end at some point, because it's constantly expanding. So as far as I'm aware, you do increase in speed. August Picard would have experienced an increase in speed, and for me, the scales gradually would have increased in terms of reading. So yeah, once again, I think we have to sort of consider the system as a whole. We can rule out Rumpus and his one-upmanship. This is my model. This is the correct and the only way to view things. But that leaves us in a big gaping hole ourselves in terms of trying to understand the basic system that we're in and the nature of everything. I could go into more detail about certain things. People don't like me mentioning Aristarchus, but I will stick to that. I'll have some more proofs coming out about that. But yeah, again, it's all about observing the system and trying to paint a complete picture and put everything into its proper place.
All I can say is I can prove apples grow in trees, and so do coconuts. And I'm pretty
prove
sure.
what trees are, James. Prove what trees are, and prove.
Well, stand under a coconut tree, wait and find out.
Prove why everything settles in the layering system that it does settle, and then prove.
Well, start with one thing. We start with a coconut or an apple.
This is descended into farce. This is total non sequitur. What's going on?
Does that mean Nathan agrees with me?
Why? What do you say, Travis?
I was saying that's a non sequitur, because it's like if I'm having this conversation with James on the beach and he says, well, don't forget about the tree, I could say, well, don't forget about the roots. I mean, it's got nothing to do with discussing the fact that a coconut is falling.
It grew in the tree. It stored
That's a non sequitur. It doesn't. Yeah.
Why is it non sequitur? It's very important. Apples grow in trees.
Don't forget about.
There's only one way they can go. If they ripen, where are they going to go?
The sun. Don't forget about the light.
Oh yeah, the sun, the leaves,
potential
water.
energy doesn't explain the direction.
Well,
simply does not.
A lot of what goes up must go down. It's Occam's razor. It used to work when I was a kid. We used to throw
that's
things
not an
in the air and
explanation.
it'd always come down. If what everyone's doing is saying, I'm going to pretend I don't exist. My hand here holding the microphone, that's no longer a rule of Newtonian physics. It's not a piece of potential energy that I'm holding back. No, there's a magic force pulling, and the instant I open my fingers, the mic is going to fall to the ground. Now, I've invented a magic force to analyze out the wazoo. I lift a bowling ball 40 feet in the air and attach it to a beam and tell you, look at the bowling ball. We're going to suck all the air out, but look at the bowling ball. Now I drop it. So how did the bowling ball get there? Someone put it there.
Fell.
How did the apple get in the tree? It grew there. How did the coconut get in the tree to fall in the first place? It grew there.
You're talking about gravity, Jimbo. Gravitational. No, you're not. Gravitational energy is the potential energy a body with mass has in relation to another massive object due to gravity.
That's not gravity, right? You're describing Newtonian gravity there, Pete, and the definition in mainstream science is not Newtonian gravity. It's Einsteinian gravity. It's the bending of space-time, not the attractive force between masses.
Yeah, I can't eat space-time, but I sure can eat an apple.
Right. So bending of space-time, that's what gravity currently is in mainstream science. Not that I'm saying I agree with that, but if you're going to say it's masses attracting masses, this invisible magical force, no, mate, that's what you're describing.
No, an apple grows in a tree, and when it's ripe, it's heavier than the density or mass of the air. The air is
But
a
it's all
fluid. It
description.
falls
It
Mass,
doesn't explain
mass
why it
creates a
does it.
gravitational field.
It doesn't explain why it does it. It's simply a description you're giving.
Well, it's a complete description. Apple grows
Yeah,
in
but
tree.
not an
You're
explanation.
describing gravity, Jimbo. Like, what
Microphone
is
in
wrong with you?
hand is stored potential energy. I
The
don't see what's
potential energy is based on gravity, Jimbo. So, like, what is your argument? You have no
The
argument.
microphone at rest. Okay, it's there because of gravity, and the body at rest stays at rest till the force acts
The
upon it.
energy is based on gravity, Jimbo. So again, like, what
Okay,
is your
so if
point?
I don't
I don't
touch it for-
understand.
I
Hold
don't
on,
get to
hold
do
on,
a
hold on. Let me just
demonstration.
get you. Hold on, Jim. So, Pete, can I just get your position? You're saying it is gravity, but what Jimbo's saying is if it's at rest and then he picks it up, gravity's had nothing to do with that. You've picked it up. So, what's your position from there?
I've been trying to explain that potential energy, what Jimbo's talking about, is based on gravity.
Yeah, you're just asserting that though, and he's saying if you have a microphone at rest and then you go and pick it up, you're inserting energy. You're
not putting energy into it.
Oh, really? So I haven't got to eat food and burn muscle fat in order to pick up the microphone. It just magically gets up in the air, does it?
What energy from your body goes into the microphone?
Energy, glucose. I burn
No.
it. I burn glucose in order for my muscles to move and for me to pick up the microphone. That's an energy expenditure in order to put potential energy, which you're saying is gravity, with no actual backing.
Yeah, but how does it store? How do you measure that stored energy? Because I don't think it stores.
How
You
tired do
burn
you
all
get
this
holding
Hold on,
it
hold on,
energy
Arwin,
basically
you've got an
to
answer.
displace
Hold on,
it
Arwin, you've
against
got an
the
answer.
forces
Hold on, you've
above
asked a direct question. Jimbo's got an answer.
How tired do you get holding it up?
No, I was hoping you'd say about the pound feet. Forget it.
Oh, okay. Well, yeah, like I say, I mean, what instrument do you have to measure that? It's foot-pounds usually, or kilos per meter above the ground, or whatever. It's
Oh,
elevation.
really?
It's
I'd like
stored
to see a
energy above
device
the
that
ground.
does that, because I'm pretty
Long as
sure
you'd
energy is
access
only
it in
measured
math, that's how you
in
calculate
actually
it. Simple.
energy units.
Arwin,
Like,
you're just talking all over Jimbo. You've asked a question. He's giving an answer. He's halfway through it.
You know, if you raise a 1 pound weight 1 foot in the air and drop it on your toe, not so bad. Raise that same can, 1 pound, 10 feet in the air and drop it on your toe, you're getting a little worse, right?
that's not a measuring device. That is letting it
Well,
go
it's
and then
still
seeing
fall
a
at 10
result.
foot
That's not a
pounds of
measuring
released
of
energy. It
potential
has
energy.
10 foot pounds to release. If it's 10 foot
It's
in
not
the
a
air,
way to measure
1
it.
pound. Pardon me? It's
That's not
measured
a
in foot
measuring
pounds.
method.
It's the simple physics of it. If you got
It's not a
50 pounds,
measuring.
50 feet in the air, whatever, 100 feet in the air, it's that's stored energy, potential energy.
Yeah, that's
Wherever
nice,
it's
but how do you
most at
measure
rest,
it?
where it be a body at rest, you can consider it's ground or it's zero.
That's
Unless
a
you want to dig a hole
consideration. How
under
do
it or
you
something.
measure it?
Foot pounds. It's a formula, a very simple one.
Really? So math
Yes.
is measurement, is it?
No, it's
Well, no,
quantifying.
but we have to have some units. Would you buy a car if you didn't know really its output and its horsepower? Its
Yeah, but
torque?
they actually measured it and then give you the results.
But what's
So it's
it
been
measured in?
tested. They
Foot
measured it.
pounds. Foot pound seconds. Every second, it can theoretically displace that many pounds, that many feet in 1 second. Those are foot pound seconds. It's a
Yeah,
formula.
but how do you
Foot
measure
pounds
that
of
when it's
potential
not
energy.
fallen yet? Where is that energy stored? How do you measure that energy?
It's based on the input values, Arwin. Height and weight.
No, it's based on the gravitational
that's not
field that
measurement.
the object is
That's
on the height.
within.
deduction.
Hold on, let's get an answer. Jimbo, am I correct that it's based purely on the height and the weight of the thing?
Absolutely.
Right. So, P, you've just asserted something that there's something else we need to take into account.
That's a deduction, Nathan.
Okay,
That's
so the
not a
object is
measurement.
within a gravitational field, and the potential energy is based.
Hold on, you've just made an assertion. All you're doing, P, is saying, we've got gravity.
Yes.
Well, that's not a very good argument, my friend. You're just making an assertion.
Well, what are you doing?
Me,
Are you not
I'm
making an
moderating.
assertion?
I've got no.
Do you make assertions?
Not in this instance. I'm remaining neutral.
Oh, okay. Seems like everyone's making assertions, so I don't understand what is that argument. I don't think that's a very good argument itself.
Well, because you're just inserting a presupposition that we have gravity, which is the thing we're discussing, and we're trying to extrapolate out our thoughts about it to give people an idea of where our feelings lie. It's just feelings, though, because there's no science for any of this, which is why I don't really care, and I'll let you all slog it out.
But we do use foot-pounds and foot-pound seconds, and it's sort of accepted
That's
as
deduction.
measurements and,
That's
and
not
for input
measuring
values
energy.
for stored energy.
It's not measuring energy. That's a deduction.
Stored potential, my mistake. There's potential weight, potential mass.
That's
Elevation
interesting.
above
So
the ground.
it's not an energy. So then where does the energy causing that motion actually come from?
What motion? Stored energy has no motion.
Downwards.
It's potential.
When you drop it, where does it come from? Why does it go down?
Well, if you're speaking of water in a dam, it's not necessarily going down and go over and out through turbines.
What if you don't drop it? What if you throw it to the ground?
Then again, the I drop the mic, I throw it to the ground, I do this, I do that. But don't count me as part of what's happening here.
Okay.
Like
If I
apples
throw
growing
it-
in
if I
trees. Let's
throw it
ignore
to
the
the-
tree, the sun, and the fact that they grow above the ground and they only have one way to go.
If I throw it against the ground instead of just dropping it,
yeah, that's not
doesn't
science. You're
it
excluding
move?
yourself from the
Isn't it gonna-
reality of the physics that you're trying to describe.
It's going to be moving faster, right?
If you don't throw it, it's not going to be moving faster.
But all objects drop at the same constant speed, right?
Not at all. The acceleration downward is, whatever, 9.8 meters per second squared, whatever, till terminal velocity of the object in question. Different
Right,
shape.
And
unless we
depending
put
on the
another
air
force
density.
on the object. If we could put another force on the object, like the force of us throwing it against the ground, and make it go faster than it normally would if we just dropped it without putting any energy into it.
Oh,
You
hold
can
on,
put
hold on.
energy
There's a
into
problem.
it
Hold
and
on,
it'll go
P, I've got a
faster,
question.
or you could
P,
put no
sorry,
energy
sorry,
into it
hold
and
on,
it goes at a
P,
constant speed.
P, I've got a question. You said if we drop it without putting any energy into it. So how did it get up there?
You moved it.
So we did put energy into it then.
No, that's not
No,
putting
you didn't.
energy in it. It's just
didn't put
I've just
energy
explained
into
this.
it.
Hold on, I've just explained. I burn
it.
glucose. Yeah, I get that glucose from sugar, which I get from food, which my body has had to metabolize and use energy to make energy to pick it up. So don't tell me there's no energy being exerted. There is.
Oh yeah, then where is that energy
No, I
stored
didn't say
in that
there's no
object?
energy
How do
being-
you
Yeah, it's
measure it?
stored in the glucose that I burnt in order to pick the microphone up, to insert energy into the microphone, to get it to the point where PMAR's example started, with it already in the air.
So where is that energy
You're
stored
using
within that
energy. The
stationary
object
object?
doesn't have any
How do
energy.
you measure
You're not
that?
putting any energy into the object.
Oh, right, so gravity is just not necessary then. You can just look at the energy I put in then, P.
You can't. There is
I
no
don't even know
energy
what you're
there.
talking about.
I put energy into the mic by picking it up. Yeah? But you're saying let's ignore that energy, because let's start at the point where it's already in the air, and we drop it, and we measure from there on in. That's what you're saying.
You don't put it
No,
into
I'm
the
saying there
mic.
is no
You
energy.
use
Hold on.
energy
You
to
can't
pick
measure
up
it.
the mic. You're
Yes,
not
that's
putting
correct.
the energy into the mic. You don't
Yes,
have
it
that
is.
ability.
Yes, it is. Potential.
Potential energy is not a thing. It's a concept. You can't
Right,
measure
I
it.
realise this is all conceptual based. None of this has any science. Please don't use that against me. There's no science for any of this.
Well, don't use our conceptions against us.
Why? That's the whole point. I'm pulling everyone's nonsense apart here.
Yeah, and we're pulling your nonsense apart.
I'm
here
not
in this-
asserting anything. Literally, I've made no assertions here. None.
All right. Well, why are we discussing it then? Because we're not getting nowhere. It's just a
No,
total
because we are going to
denial
get nowhere
fest of
indefinitely, which is why I can just pull it apart all day long, and it's just all it's doing is chewing out time that we spend on these debates, which is fine. Hi, Dave. How you doing?
everything. Sounds kind of like
Greetings.
a waste of time.
Good to have you. Thanks for joining.
Nathan,
No problem. Carry on, lads.
Nathan,
You are applying
aren't
energy
you-
to displace it from its natural.
Hold on,
ask you the
Pete.
same question that
Pete,
James
hold on.
did?
Go on, Travis. Just not quite quick enough, Pete. Sorry. Go on, Travis.
I hear your question. Your question about the mic situation is the same thing with James bringing up the tree. You're saying don't forget about raising the microphone up to the height thing. Don't forget about the tree. I mean, that's the same analogy, right?
Well, not really. If you say a mic will fall, it's like, well, will it? It's just a mic, right? It's a concrete noun. There's no phenomena unless you create one.
Yeah, okay.
You're applying energy to displace it from its inverted commas natural position. And this object then has a tendency to regain its natural position. And I use natural, as I say, in inverted commas, because I don't think there's anything natural in this system that we're in. Again, we have to consider the bigger picture, the picture of the whole. And as if we don't start looking at these greater things, we'll just get stuck, as you say, Nathan, I can understand your point of view exactly with the scientific methodology, but it has its limitations and it won't allow us, it will allow us to rule things out, but I don't feel it will allow us to rule lots of truth in, or potential truth in anyway.
Right, but the correct tool for this would be science if you want to establish the cause of an effect. But what we're doing is saying, oh, it sits outside the boundaries of science, so let's just philosophize about what could be causing it and then assert that as science. That's what everyone does.
Right. Yeah, well, we don't have to assert it as science then, but if science can't explain something, there isn't a truth attached to it, you see. So if you rule everything out that you can't define under the scientific methodology, then that would leave a gaping hole, you know, where there can be other routes to finding out truth. So this is the whole point.
Right, you've just changed my word from cause to truth, though. You know,
Well,
we're talking about causes.
Yeah, well, truth is in, look, we're here to try and investigate the nature of this reality we're under. And I've heard you mention before, we can't sort of perform any scientific experiments regarding, say, the luminaries. But that doesn't mean we can't come to understand what the luminaries might be. You know what I mean? This is the point. And that they won't, understanding that they won't play a bigger picture, a bigger part in the bigger picture that we are trying to sort of paint for ourselves. That's all I'm trying to say.
Well, yeah, but we sit on the same side of the argument, though, Pete. So in that regard, yes, I've got to agree with you, but that's not what we were presented with. So we're presented with the cause of those luminaries is the Big Bang.
Right. So I've ruled all this shit out already, excuse my language, because everything that official science has presented us is an inversion of truth. But there is a greater picture here, and I've often said this about coming to flat Earth realization. We've entered a whole new realm of wonders, really, and we have to be open to considering all manner of possibilities. Because after all, if this is a divine setting at its very core, well, the scientific method will not be able to analyze in detail all the ultimate root causes to everything, you know. I have foregone the Big Bang and pretty much all of science's explanations for the root causes of everything. But I haven't.
Hold on. I've got to check you on that again, Pete, because that's what science does. It establishes a cause in a cause and effect relationship, and you're saying, well, if it sits outside, we can still search for truth. And it's like, well, what is true about a cause is established with science. So when it comes to people talking about causes that they can't establish and then calling them invisible forces, like, this is nonsense. This is all pseudoscience. Frankly, I don't care about it. You can argue about it all day. And I'm quite content to join people's side when they're demolishing somebody's just so story about an invisible force. Yeah, man, give me that bat and I'll smash their head in with it. No problem at all. I'll demolish that nonsense. But my problem comes when somebody else then asserts, well, what is the cause of this invisible force that we don't see and cannot quantify or test or isolate? You're like, what are you talking about? There's no phenomena here. What are you talking about?
Right. I do understand the difficulty.
If we can't agree on why an apple that grows in a tree falls to the ground, how are we going to figure out the luminaries? We're not there yet. We can't even agree on things falling. You know, a microphone in your hand, and people can't adopt the idea that you're holding back potential energy, that you gave the mic the potential to fall. When you open your fingers,
God,
let it fall. Yeah, we're right back to, simplicity, like Occam's razor.
Hold on, Jimbo. P. Mars wants to assert that gravity's just real, so let him make his assertion, and then we'll move on.
Right.
Gravitational fields are real.
Thank you, P.
Yeah,
You're a
measure
credit
them.
to this debate.
It's the same kind of nonsense as potential energy. Measure it. How do you measure it? Field? Like
You measure it with the
magnetism? Measure it.
Cavendish experiment.
Energy? Like potential
Excuse me,
energy?
Cavendish is not
Measure
an
it. How do you
experiment.
measure it?
Again, the phenomena isn't there. You conjure the phenomena within the experimental apparatus, so it is not a scientific experiment. It is just a circus sideshow.
Exactly. Both
What?
of these examples are.
I'll say it again. The observed phenomena is conjured within the apparatus. A bit like Rumpus saying that a scale is an observed phenomena. It isn't.
The Cavendish experiment shows that two masses are attracted to each other.
What's the observed phenomena? What's the effect, P?
They put like two different weights on a torsion balance, and then you can watch them be attracted to each other.
Oh, really? And where do we observe this? In the natural world? My bad, it's an experiment that you're setting up that you're now saying is an observed phenomena. That's not how science works. Step 1, observed phenomena. Not step 1, observed phenomena in step 5 from the experiment. That's not how it works, P. That's not science, mate. It's not a scientific experiment. It's a circus sideshow because it doesn't have a dependent variable that's viable, i.e. an observed phenomenon.
It does have a dependent variable.
What's the dependent variable, P? What is a dependent variable, P? What is, specifically, is a dependent variable?
You want me to Google it?
No, just tell me what it is. You're saying it does have one, so tell me what one is. What is a dependent variable, P?
A variable whose value depends on another.
Yep, there's another word you're missing. It's your effect, P. It's the effect. It's the observed phenomena. That's what it is. It's the effect in the cause and effect relationship. It's the effect. Okay, P? So what effect are we studying in the natural world for science?
The effect of mass attracting other objects.
And where did you observe this?
Well, like when the apple falls out of the tree.
Oh, sorry, that was an object of mass attracting another mass?
Yes.
Oh, really? Why?
Of course, what else would it be?
Oh, so it's just your assertion then?
No, it's just an observation.
Oh, so it's not... So, let me get this straight. Your observation is your conclusion.
The observation is masses attracting each other, yes.
Right. So, your observation, the phenomena you are studying, is an apple falling from the tree.
Yes.
Where's that in the Cavendish experiment?
In the Cavendish experiment, the larger weight would represent the Earth, and the smaller weight would represent the apple.
Hello, FE Astronomy. How you doing? Hello, Mike. Can you hear us? Give him a second, see if it is genuinely Mike.
Hey guys, can you hear
Hello.
me?
Good to have you.
Thank you.
Very well.
I'll just listen in for a while and I'll add my bit in a sec, okay?
Yeah, no problem. So, what you've said, P, is we observe a phenomena, the apple falling from the tree. What we would do in science is then establish the cause of that effect. You're now saying, not effect apple from tree, effect Cavendish experiment. Right, do you see the disconnect there, P, or not?
Oh no, I can't really follow what
No,
you're
that's
saying.
okay, P. Don't worry about it. Go back to one of the multiple shows where we rip the Cavendish a new asshole. We've done it on multiple occasions. It's okay if you don't understand it.
I don't understand how you can rip it a new
Yes,
asshole.
I know. You had to ask me if you needed to Google search what a dependent variable is, P, so it's okay. We can move on.
Like, you've seen the experiment.
No, P, we can move on now. Yes, you've demonstrated that you don't understand this, and you don't understand it, so let's just stop talking about it. Cavendish is not a valid scientific experiment. Okay?
It is. How would you?
Yeah, you're just making an assertion again, P. Right? I've just ripped it apart, and you don't understand how I've ripped it apart because you don't understand what an experiment is. Because you had to ask if you should Google what a dependent variable is.
What makes you the authority of what science is? You're a grocer.
I'm not. Okay, P.
Why
I'm
do
not
you
asserting.
act like you're an authority of science, telling people what
Oh
science
God!
is?
Don't start this nonsense, P. Just
Well,
let's
you
move
do that
on.
all the
You
time.
don't have
I
to become
understand.
angry.
You don't have you have a very limited knowledge of science, and you sit here acting like you're the authority on it, the subject.
Really?
What
Says the
experiments
man
are?
who
Yes.
has to Google search what a
You're the one
dependent variable
asserting
is.
what experiments are and what science is, and you
Right.
don't have any qualifications
Okay.
or experience in your life to do such things.
Jolly good. Okay. Thank you, P.
All right. You asked the question of how you can justify the attraction of the two objects.
Yep.
Yeah.
You
So
see them.
no. Hold on. I'm asking you now to justify the attraction. What is that? Where are you getting that?
In the experiment, it shows two objects being attracted to each other.
No.
And
not
the only
attracted.
independent.
Attracted is a very specific term that has implications. You are inserting something that is the cause of the attraction. So we still have to peel back the onion. What's the cause of the attraction?
Mass.
Mass.
Can I just interject something, please?
Sure.
Yeah, go ahead.
The discussion has been going on for a while. What is exactly exerting force on what? And it's not mass. Mass does not create a force. It does not create an attractive force, and it does not create a repelling force. But everybody on both sides of the fence seems to ignore the electric force that has an attractive and a repelling nature. We know that the Earth has a positive charge and the air surrounding it has a negative charge. That creates a direction, right?
Absolutely, like with a magnet.
Then you have your force. That's your force, electric force, the direction of the current flow.
So, am I right in saying, Mike, that in essence you're saying that what creates the direction down is an electromagnetic force as opposed to any attraction between...
Not an electromagnetic force, an electric force. To be very specific, electrostatic force.
Electrostatic, okay.
There is a difference in charge potential, and that charge potential has a direction, and that direction is always to the positive charge. And the positive charge is under our feet. That is why we are attracted to Earth. Has nothing to do with mass exerting a force on another mass. You know, Cavendish is a load of crap, because if you perform that experiment and you let the camera roll for about 30 minutes or 60 minutes after the beam comes to a full rest, you will see that the beam has a tendency to start moving away from the mass. So always ask for at least 30 or 60 minutes of footage after the beam has come to a rest. And you will see that it just moves in the other direction.
And do you know why?
It could be all kinds of conditions like environmentals, vibrations, resonant frequency, you name it.
How about because it's the twisted tension in the cord holding the bar is unraveling?
And you can raise mass with magnetism, but you can't raise magnetism with mass. So the attraction may not be electromagneto or electro, as you put it. It may just still be volumic mass of matter.
Yeah, well,
densities, what people are saying all the time.
The entire gravitational constant that is based on the amount of mass present, you know, that has a big G, and big G, when you start to implement that, let's say in a deep mine shaft underneath the Earth, let's say 100 or 1,000 or 1,500 meters below the surface, you will see that it totally falls apart. You can't use it anymore. So it's not a constant. And it's
what
not
falls apart? In
Yeah,
the tunnel, in the hole?
Sorry, how do you mean? Can you qualify that? Oh, we're getting trolled. At this point, I need to ask people from the audience to join just to fill a few gaps. Otherwise, this is the end of the conversation as we're being trolled, which is deeply unfortunate.
Okay.
Hopefully, we'll get a few guests to join from the panel. Click the link in the info box. You join and we end up getting sniped. Obviously, it'll mean we'll have to start a new hangout, but hopefully, a few members of the audience will join and we'll have normal service resume shortly.
Okay, I posted a video in the... Yeah, of course. The mass...
Bloody trolls. I think we need one more person. I think that's it. I think we're full.
Okay, I posted a video in the comment section about on the I think it was the debate of yesterday, which is a presentation by Wallace Thornston from the Electric Universe. And he basically breaks it down very, very well, gives practical examples and actually shows that the entire gravitational constant based on mass attracting mass is a load of crap. You can just switch mass for charge potential and you will have the same outcome in your equation. So cool. Mass is not force, or mass is not creating the force.
Yeah, we need one more person to fill the panel up again, if you may. Hopefully we'll get another member of the audience.
If the mass attracting mass crowd is asserting that mass generates a force, then you need to prove that. And don't give me that.
God damn. Time to battle the trolls again. We've got a full panel now. Hopefully so.
Okay, no, and what I inserted into the comment section yesterday was that both sides of the fence need to watch that video. You know, the Electric Universe basically is a baller. How do you say that? They think the Earth is a sphere, and that's okay, you know. But the science they do is pretty good. You know, I understand a lot of what they're saying because I have a engineering background, so I know what they are talking about, and it makes real sense. But listen to it, everybody, not just the flat earthers, also the ball earthers. You know.
Oh, I've seen the whole series actually for the Electric Universe and what is it? The Catastrophic Geology, by Michael Steinbacher, and all that. The whole works there, A through Z.
Yeah.
They're very, very ball-oriented, and well, in a sense, to me, it's almost like creating a new religion there. The cave writings, all plasma figures and stuff, the realignment of the planets, the pedestal to the sun that they depict, all kinds of stuff is probably and quintessentially just painted into a nice package. They're right about a lot of the electrical nature of our universe. Don't get me wrong. I like a lot of what they've done, but they're certainly don't take it as gospel. And use good discernment. It's just like any other information out there. Try to take in as much as you possibly can before you draw any conclusions, and make your own mind up about stuff.
Yeah. Well,
like almost a cult to me.
The presentation that I sent is actually. There is a lot of heliocentric terms being used. You just have to swallow that, so to speak, and just listen to everything else that he has to say, because he's basically on both sides. You know, he is a baller, but he is also saying that mathematics, the way that mathematics is used now, is a load of crap. You know, mathematics is not physics. You know, if you have an entire whiteboard full of symbols and you don't know how to define those symbols literally, because nobody has a definite definition of mass, for example, then what the fuck are you writing on? What the hell are you writing on that whiteboard if you are unable to break down the symbols on the whiteboard? No, and there are symbols on.
Let's face it, we have an accepted mass and atomic mass units, scales that work on kilos, grams, and etc. We have the avoirdupois system. Some things are sort of accepted, especially the mass system with kilos and stuff. So yeah, there's abuse to math and magic applied to math and distortions and everything. But I look at what is practical in the physical world. Like there's some math that the formulas apply to different things. For example, filling a swimming pool with 3 different size hoses that have 3 different volumes of water or rates of flow. You can calculate that with the reciprocal of reciprocal sums formula. Well, guess what? The same exact formula works for any parallel circuit. So you can fill a swimming pool, or you can calculate the current in a circuit, a parallel circuit, the same way in the same formula. Absolutely no difference. So if something has congruity like that, and with the rest of the system, parts of it I got to be okay with. I have problems with the astrophysics nonsense, all this magic of space, whip effects, orbits, gravity as a tether. No, you see where I'm going? If it's practical and if it's congruent with other elements, it's fine. It probably does work, even though it's fictitious. Like my big term is there is no electricity on flat Earth, believe it or not. From the power stations to your house, these are high tension wires, and there's only a tension applied, a push-pull, a rocking, a tension. No electricity flows, no so-called electrons flow.
Before we get into that, Jimbo, I'm really sorry to just cut you off. Mike, do you have a link to the video you were referencing? I've just gone through the last 3 debates to try and find your link, but I couldn't find it.
Yeah, let me just find it. Give me a minute or something.
No problem. If you stick it in the side chat, I'll grab it and then stick it in the public chat.
I give the example of how cars are wired. In Britain, they have a positive hole theory for, the current that flows through your automobile. Here in North America, it's the negative post that flows electricity to the positive. In England, it's taught that there's a series of holes and the electrons drop into the positive holes. So the whole theory is different. But you turn your key in a car in North America or you turn one in England, even though the 2 theories of electrical applied to them are absolutely different, they both start. So I don't know. With anything, I guess it's simplified and taught in the most simplistic way that it can be, except of course for gravity and astrophysics.
Yeah, well, the gravity is a loaded term when you use it now, because when we or anybody says gravity, we always imply that it's mass attracting mass. But nobody can prove that as soon as you have mass that there's a force present. Nobody can prove that.
Well, in acceleration downward, the actual formula for 32 feet per second squared till terminal velocity, there is no gravity. A lot of people and professors will insert it and get all convoluted and newtons of force downward and vectors and, oh yeah, okay. But in reality, just for the calculation of the 32 feet per second squared, there's no gravity involved. You do your calculations, there's no G. It's a fictitious force, just like Coriolis. They write it in just to add a lot of fiction. Look, the Coriolis, the guy shoots a .5 rifle straight up. It should move him, the Coriolis, and the spinning axis Earth, a gun in the shooter, about 16 miles at 45 degrees latitude. But the bullet comes down at his feet a minute and 50 seconds later. Where's your spinning Earth? You're supposed to calculate Coriolis at 1,200 yards with a .5.
Well, the spinning of the Earth is another topic for debate that has been going on a few days ago. I think and there was some unclear things about what Chris Seeley had to say about the gyroscope issue and the rotation it registers.
Well, a minute and a half airtime on a bullet is very substantial.
Yeah, Well,
the rotation underneath that bullet should be immense. 300 at the equator, 300 yards a second. A football field a second. So at my latitude, it'd be 150 yards a second. 16 miles. It should pull me and the gun away. Should be safe as hell to just not even look for shelter.
Yeah. Well, there is a discrepancy between the two types of gyroscopes that we've used so far. We have the optical gyroscope, the fiber optic gyro, and the ring laser gyroscope.
Mm-hmm.
You have the pure mechanical gyroscopes, the directional gyroscopes, basically the ones that they use in airplanes for the attitude meter. The optical gyroscopes all register a rotation. They all do. But the mechanical gyroscopes do not. Not one. There are several.
Did you ever think it might be Ferris wheel programming in the device added?
No, the mechanical gyroscopes do not drift at all.
No, I know, but the new ones do apparently.
No, that's just the optical ones, and the optical ones do not work mechanically. They work with light.
But could it be programmed in?
No.
A merry-go-round? No, it can't be programmed in, eh? They don't have computers doing calculations and applying algorithms, nothing like that.
Yeah, sure. You can think.
Oh, yeah, sure.
If you break down the firmware, you should be able to see it, and it's not there. Fiber optic gyro just processes exactly like it should.
So the black box flight recorders register the curve of the Earth as the plane flies over it.
I'm not saying
they don't not apparently.
I'm not saying that they measure curvature of the Earth. I'm only saying that they measure rotation. But rotation of what? Now the ballers will immediately say it's the rotation of Earth. Well, I always say that's baloney because the mechanical gyroscopes do not register the same drift.
Just another toy, spinning toy.
It's just the optical gyroscopes, and if optical gyroscopes work with a different method with light, my assumption or my conclusion about that is that it's a rotational ether field that we're measuring. Because mechanical gyroscopes should, by definition, also drift with the same amount per latitude, but they don't.
Well, that means all the pilots that ever flew those old Cessnas and stuff that didn't have all this modern cockamamie stuff really couldn't get to where they were going.
Exactly, if they drifted.
Or drifted or crashed.
Then they couldn't, but what they say is that a counter torque is put on the gyroscope that prevents it from drifting. But we have tested several mechanical gyroscopes, and none of them drift. None of them. They're all stationary. It doesn't matter how you make your experiment set up. If you put it on water, on a floating device, or just on a solid table, they remain stationary. There's not a degree of drift. And if there is drift, it's imbalance in the mechanical gyroscope itself.
Yeah, it's as phony a test as a Foucault's pendulum. Same guy made them both.
Yeah, well, the story goes that Foucault's gyroscope did measure that drift, but that's ludicrous because we now get the excuse that friction in the bearings prevents the mechanical gyroscopes from drifting. But
I doubt he had one that could spin for a minute and a half.
Yeah, that sounds about right.
Sorry?
About a minute and a half for him using a contraption to mechanically wind up that gyro. I mean, I would be surprised if he got a couple of minutes out of that gyro with nowhere near as good as what they class today as a child's toy in terms of the bearing quality.
Correct.
Is that not why you use the pendulum?
Minus the time it takes to stabilize.
Yeah, that is why they use the pendulum, because the gyroscope looks very bad for their argument.
Well, for my limited understanding is he did find drift in the gyroscope, but
so why don't we? So why don't we, with much better gyros that spin much faster for much longer with much better bearings, why wouldn't we see the same as Foucault saw?
We have 21st century technology and our bearings are 1,000 times better quality than what Foucault had.
But the other gyroscopes do show drift.
Just the optical ones.
With their gyroscope on a string, just amazing.
Optical gyroscope work differently than mechanical gyroscopes. And you can ask every gyroscope expert, a pilot, they will all say that mechanical gyroscopes are better equipped to measure the apparent drift or the drift per latitude. And they don't. You know, everybody says that they do, and they show me the diagrams and the papers saying that they should, but nobody has ever sent me a video of an experiment showing that. You know, Wolfie 6020, for example, a pilot, he should have video after video after video showing this exact rotation of a mechanical gyroscope. And he doesn't, because it doesn't exist. It's not present.
And how many times have you seen the mechanical gyroscope not drift?
How many times? You mean how many different gyroscopes, or how many hours I've spent working on gyroscopes?
Both.
Well, we've been working on the gyroscope group for, I think, about 14 months now. And I've seen 4 different mechanical gyroscopes for several hours do exactly nothing.
And you've got all the settings right to allow that experiment to be correct?
Yes, yes. We tried different environmental settings, different contraptions, different gimbals. Doesn't matter. Stationary.
But fiber optics gyros do show drift?
Yes.
Okay.
Yes, and they drift according to latitude. So the formula is applicable. But, you know, the conclusion, you can draw 2 conclusions from that. Either it's the Earth that's rotating, or it's the ether that's rotating. And both are valid.
Wasn't the ether disproven in 1890 or something?
No. There was an argument placed that if the gyroscopes register, the optical gyroscope register this rotation, then that same drag should have been present in the Michelson-Morley experiment. And everybody says that it wasn't, you know, but it was.
Do you know your latitude?
I know my latitude is 50.
What's your latitude? 50?
52 north.
So you should be 160 yards a second or so, or travel in speed. So if you fired a 50 cal straight up, would you seek shelter, or would you depend on the 15, 16 miles that the axial rotation of the Earth is going to move you from underneath that bullet?
I'd run like hell.
1 minute, 50 seconds return time it has.
Yeah, I would seek shelter.
Yes, because you can't depend on the axial rotation of the Earth to remove you from underneath it, can you?
No.
It does say here on Wikipedia.
It means the Earth is not spinning, right?
Exactly.
You can see that the Earth is not spinning.
Yes.
It does say a fiber optic gyro provides extremely precise rotational rate information, in part because it lacks of cross-axis sensitivity to vibration, acceleration, and shock, unlike the classic spinning mass gyroscope.
Mm-hmm.
So would that not indicate that it's a more accurate tool?
I'm not saying it's more accurate. I'm saying it's more capable to register rotation.
And it finds rotation?
No, only the optical gyros find rotation.
Yeah, exactly, yeah.
But rotation of what? Answer this question for me. Rotation of what?
It can be programmed in like a Ferris wheel or a cartwheel.
No. Rotation of what?
Maybe a programmed in rotation, a numerical rotation only, and not an in reality rotation.
No, because the rotation even has a vector.
A plane can fly in any direction. If it flew in the vector of the direction of the ether,
well, wouldn't
it register less or more on that rotation?
That's my conclusion. I don't believe that the Earth is moving, but and I base that on the extensive experience and experiments that we've done with both types of gyroscopes.
But you did just say that the optical gyro does show rotation or just show movement.
It registers drift according to latitude.
Okay. What does that tell you?
Answer that question for me. It registers rotation, but rotation of what?
You're looking for the rotation of the Earth?
No. Because
why wouldn't it register longitudinal motion?
Or why doesn't it topple, for example?
If I understand right, if you spin it, say you're at the North Pole, hypothetically, you spin it up, and then you go to the South Pole. You're upside down, and it's right side up. If we're on a ball, it still maintains the North Pole orientation.
That's what. Yes, but you know, none of the gyros, mechanical or optical, find curvature.
No, but they show the rotation of the Earth, though.
No.
Only one of them does.
That's your conclusion, because you believe in the ball spinning. I'm saying it's the ether rotation, and I can prove it based on Michael St. Morley results. You know, they registered a null result because they were measuring the speed of the Earth going around the sun.
Have you actually read
Oh, I'm still talking.
Sorry, I do apologize.
They measured a 1 to 10 kilometer per second drift on the north. Sorry, my baby just woke up. Yeah, on a north-south trajectory. That means that they measured a drag, and they considered that a null result because they were looking for the orbital momentum, and they didn't find it, but they did find a drag in the light. Now put that back into an optical gyro, which works with light, is susceptible to that same drag. You know, the Michelson Morley was a stationary light beam, and it shifted. So why wouldn't a fiber optic or a ring laser gyro do exactly the same thing?
I thought they were looking for ether, not the rotation of the Earth.
No, the Michelson Morley was to find the orbital momentum, the orbital speed around the sun, and they didn't find it, but they did find a 1 to 10 kilometer per second drift in the south to north beam. It shifted. So that's the drag of the ether that I am referring to. That's the rotation that we're measuring with optical gyroscopes.
I'm quoting Wiki, so whatever you want to say about that. It says about the experiment, it compared the speed of light in perpendicular directions in an attempt to detect the relative motion of matter with a stationary luminous ether.
Yeah, but the speed of light is dependent on a medium traveling in.
I wasn't finished.
Okay, sorry.
No problem. The result was negative, in that Michelson and Morley found no significant difference between the speed of light and the direction of movement for the presumed ether and then the speeds of right angles. That they were looking for ether and they couldn't find it.
No, that's not. Hold on. Can you just read the part about stationary matter again?
Yeah, sure. Where are we now?
It's right near the beginning.
I have to mute, by the way.
Hold on. I just wanted to repeat what the test was.
It compared the speed of light in perpendicular directions in attempts to detect the relative motion of matter through...
Stop! So they are trying to detect the relative motion of matter.
Yes.
Right. What does that mean?
Through ether.
It's matter moving through ether. So they are trying to detect the matter moving through the ether. The matter. Excuse me, why are you now talking over me, dick brain? Is it because we have just demolished your assertion that they are actually trying to find that the ether is rotating and that's why it's a null result? Or is it because you don't understand that the actual definition is that the matter is moving? That is what the test was. Excuse me, the matter is moving through the ether, according to what you have just stated, correct?
They were measuring if the Earth was moving through the ether with a 100,000 kilometers per second motion.
Correct, and it was a null result. They did not detect that the Earth moved through the ether. The matter did not move through.
Can Dick Brain say something?
That would be you. Sorry? You can say something if you want.
The result is generally considered to be the first strong evidence against the then prevalent ether theory. Initiated a line of research that eventually led into spatial relativity, which rules out a stationary ether.
You're quoting Wiki, right?
Yeah. Okay, I've actually read the actual experiment itself, but go on.
Okay, but did you also read that they registered a drift on the perpendicular beam from 1 to 10 kilometers per second? And they discarded that as a null result because they were looking for a much higher speed?
I can't remember that exact terminology.
No, it's not exact terminology. I'm paraphrasing what they were looking for.
Okay, wait, I meant your exact terminology.
They were looking for the orbital momentum of Earth going around the sun through the ether, and they didn't measure it. But because they assumed that the Earth is moving, they discarded the ether.
Maybe we should all read more about it.
Yes, please do.
I mean, I meant all of us.
yes, there are so many conflicting stories about both the Michelson-Morley, Michelson-Gale, and the Senyek experiments. There's also a lot of misconceptions about Einstein's general and special relativity theories, because they are still theories and they are actually discarded because c is not a constant speed, it's medium dependent. Everybody knows that. So I'm not quite sure why. Also on the gravity argument, why you guys keep holding on to something that is metaphysical, it's unprovable, and it's actually fairly easily debunkable.
And with that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you liked the show, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!